Geometry, Chapter 7, Section 5, we're going to look at some trapezoids and kites. Again, staying in the quadrilateral family and looking at just a couple of different shapes. So let's pull up a trapezoid. We'll start with it. And there are two different kinds of trapezoids. We're having board troubles. There we go. The first one, this one, excuse me, this one is isosceles. And I'll go ahead and put isosceles trapezoid. Okay, so an isosceles trapezoid, excuse me, is when the legs are congruent. And so the legs are going to be the non-parallel sides. So when they are congruent, the base angles are also congruent. Okay, so an isosceles trapezoid has one set of parallel sides. It has one set of congruent sides, and then it also has it has two sets, excuse me. The above base angles are also the same, although they are not the same degrees as the lower base angles. Something also I could, let me see if I can clone this. Let me get the whole shape. There we go. If I have this, I could also draw in the, give me a line. There we go. I could draw in, oh, that's terrible. There we go. So it's more eye level for me. I could draw in the diagonals, and in an isosceles triangle, the diagonals are congruent to each other. But unlike a parallelogram, they do not bisect each other. So the diagonals are congruent, but they do not bisect each other. So we also have just a standard trapezoid, and I'm going to go ahead and just draw one of those. Let's see, I'll make that one. Okay, and so this may not necessarily be an isosceles trapezoid, just a standard trapezoid. It does have one set of parallel sides, but in this case, the diagonals wouldn't have the same relationship, and the base angles and the second set of opposite sides would not have a relationship. However, we can get a mid-segment out of this. And so if I were to take the midpoint of these two, of the two non-parallel sides, and connect them, oh, yikes, I don't like that. Let me get that with a line. It's just at a little bit of an angle, that's why it does that. Whoop. That would also be parallel. And let's put some letters on here. Let's say this was originally A, B, C, D. So then we'll call that EF. And in the mid-segment theorem of a trapezoid, your mid-segment, I just put EE. Nice. Let's go with F. Your mid-segment, which is EF, is equal to 1/2 of the sum of your other two parallel segments. So EF is 1/2 of the two parallel segments added together. And so let's say that the top one is 12, AB is 12, and DC is 28. Okay, so EF would be 1/2 of 28 plus 12, which is going to be 40. So EF would have to be 20. Okay, so pretty straightforward. Okay, so let's look at a kite. I don't know if we have a kite shape up here. We kind of do. There we go. If it'll let me, there we go. So let's go like that, and let's rotate it so it kind of looks like that. Now, in a kite, we've got a couple of properties, a couple of additional properties. We could take the diagonals, and if it's a kite, those diagonals are perpendicular to each other. Okay, so just like the rhombus and the square, the diagonals are perpendicular to each other. And in a kite, there is exactly one pair of opposite congruent angles. So if this was a kite, then B and D could be congruent. We couldn't have two opposite pairs of congruent angles, because then that would make it a parallelogram, a rhombus, or any of those others. So that's its specific thing. There's only one set of opposite angles that are congruent. And also, the sides of the kite, this isn't a great drawing of a kite. This is not going to pass the eye test right here, but truthfully, in a kite, if AB is congruent to AD, then BC is also congruent to DC, but they are not all congruent to each other. Again, same philosophy. If they were all congruent to each other, then it would be a square or a rhombus and not a kite. And so that's a little bit under 9 minutes. We've got Chapter 7, Section 5, Trapezoids and Kites.